Well, hello there, everybody. I hope you guys are having a wonderful day. So, look, here's what I wanted to do. We're doing a little distance learning, so I thought maybe if I did a crash course in exponents, it might kind of get everybody on the same page and stuff like that, right? So, we're going to use these fancy pens. Nothing but the best for you guys. You ready? All right, so first thing, let's talk about this might seem kind of strange, but let's talk about addition. Look, let's do 5 plus 5 plus 5. Isn't that the same as 3 times 5? Uh, this number right here describes how many of these there are with repeated addition. So this is right here. This is multiplication is repeated addition. All right. Now, I'm actually going to argue that maybe this is written backwards. Maybe it should be written this way. This is 5 3s. It doesn't matter. They're both the same value, right? Of course. Whereas, let's take a look at this. Let's see if we did 5 times 5 times 5. Well, that would be 5 to the power of 3. Do you see? Um, this is exponents. And what exponents are is they're a way of writing repeated multiplication. You see? So this is an exponent, right? This right here, this little symbol right there, this symbol right here, that's multiplication, right? So as you guys know, right, this is probably not new, but it's worth stating because this is where we start. Uh, Exponents. The reason we use exponents is that we don't have to do the calculation. The reason we use multiplication is because we don't always have to do the calculation. It's a shorthand way of writing a large number, right? So a shorthand way of writing a large number or really small, like if it's got a negative exponent. Okay, so that's the reason that we use exponents. And when you understand that, then you can start looking at exponents as not a problem to solve or anything like that. It's just a way of writing. Math is a written language, and this is one of the tools, one of the writing tools. Okay, so check this out. You guys probably all know this already. So let's talk about 7 to the power of 4. You guys probably know this, but just to make sure, that number right there, it's called the base, and the base is what's being multiplied. This is the exponent, and it describes how many times that base is being multiplied. So this would be 7 times 7 times 7 times 7. And unless it's a really easy calculation to do, you're just going to leave the number like this. You're not actually going to write it out and multiply it. Now, it kind of defeats the purpose. The whole purpose is that you don't actually have to do the multiplication. You can just write it like this. Okay? So, moving on. Onward and upward. Let's use our good old fancy Dixon Ticonderoga number 2. Man, look at this pencil right here, man. This is high quality. Okay. Hashtag not sponsored by Dixon Ticonderoga number 2. Oh man, it is a good looking pencil though. All right, so anyway, let's talk about some of the patterns, right? People call them rules or properties, but they're just patterns of exponents. So, for example, let's say that we had a to the power of 3 times a to the power of 2. Now, the way that we say it is if the bases are the same, these are the same bases, that you're multiplying, you add those exponents, right? So this would be a to the 3 plus 2. But let's see why that's true. Let's see why that's true, because you're going to mix up these rules. Almost guaranteed. You're going to mess up the rules, especially if you don't understand where they come from. So let's talk about where this comes from. Look, a to the third is a times a times a. And then that is being multiplied, right, by 2 more, a times a. Repeated multiplication, that's what we use exponents to indicate. These are 5 a's being multiplied. That's why we add. Do you see? Now, there's something that's a little different, though. What if it was something like this? This is where people get into big trouble. All right, so now, this is totally different than this. These two things are totally different. Why don't you go ahead and pause the video, see which one, try them both, see if you get a different answer. Because look, they are totally different, and this is where people really get into trouble. They see this, and they read it as though it was written like this. See, look, here's what this one is. This one right here is going to be a b to the fifth, or a to the fifth, b to the fifth. But this one is not. This one's a squared b to the fifth. Not the same at all. The reason why is, you see this right here? Only the b has the exponent of 3. This has an exponent of 1. This has an exponent of 1. The b has an exponent of 2. Do you see? Here, a and b both have an exponent of 3. They're grouped together with that exponent. Ah, yeah. Okay, so be really, really careful with that. So this is part 1. This is part 2. Let's do part 3 now, shall we? Part 3. Let's say we had a to the third squared. Now, the rule is when you raise a power to a power, then you multiply. So this would be 3 times 2. And so that would be 6, of course, right? But let's see why that's true. Look at this right here says that the base is being multiplied by itself 2 times. The base is a cubed. That's a cubed times a cubed. And just like we just saw, if you have same bases and you're multiplying, you add those exponents. A to the sixth. You could write them all out too. 1, 2, 3, all multiplying, times 3 more. Do you see? A to the sixth. Dang, man, this is fanciness right here. This is just the best thing ever. All right, let's go on. Let's move onward and upward to more wonderful and fantastic, great things. Let's talk about the fourth thing we're going to talk about here. So we got raising to, we got what a base is, what an exponent is. We've got multiplying with bases the same. We've got recognizing which part has which variable, and we've got raising a power to a power. So now let's talk about our good old friend division. Oh man, let's talk about this one right here. Okay, now the rule is if the bases are the same, and that's absolutely key, because if it was this way instead, the bases aren't the same, and you can't simplify that, right? But if the bases are the same, then here's what we got. Would you guys agree with this? That numerator is a to the fifth, right? And this one is a to the third. Well, we can reduce this. We can reduce. Look, this is the same as a over a times, see there's one of them, times a over a times a over a times a times a. You could say those are both over 1, right? So look, something divided by itself, 1 times 1 times 1. That's all 1. 1 times 1 times 1. A times a is a squared. Boom, done. So the rule is this. What you do is if the bases are the same and you're dividing, is you subtract the top minus the bottom. That's the shortcut, right? But this is the reason why. And this is where people really get into trouble. Look, I don't like this method, actually. I prefer to think about it like this. Look at this. Look at this. Ready? Watch. This is going to be fancy right here. I'm not even going to charge extra for this. But you see this a to the fifth? There's 5 a's there. On the top, there's 3 on the bottom. When you reduce, there's 2 more. There are 2 more on the top than there are on the bottom. 2 more on the top than there are on the bottom. Well, check this out. Which one has more? The numerator or the denominator? The denominator has more. It has 2 more. Do you see? Man, that would be like this right here. This is where we get into trouble. Check this out. A to the third minus 5. See, it's the top minus the bottom. That would be a to the power of negative 2. Oh man, and we're saying, look, we're saying that this right here is correct, and we're saying this is also correct. And I know that's correct because look, a to the third is 3 a's, a to the fifth is 5 a's, right? Would you agree this is a to the third? And this is a to the third times a squared, that's a to the fifth? Well, this all reduces to 1. This is true. That means that if this is true, and this is also true, that means that a to the power of negative 2 has to equal 1 over a squared. Dang. Wow. All right, so wait, hold on. This is going to be part 5 right here. Look, this is part 4 right here. This is part 4, and that is division, right? You can subtract top exponent minus the bottom. You can do that if the bases are the same like they are here, right? But now let's talk about negative exponents. Oh, man. So look, let's talk about, let's do this right here. This is number 5, right? Number 5. So negative exponents. Negative exponents. Man, I know this is probably too fast for initial learning. So you might need to pause this and come back to it. Make it into digestible chunks. So anyway, negative exponents. So here's the rule. Negative exponents, you're going to do the reciprocal. And here's why. Look, negative, it means opposite. Like 5 and negative 5, those are opposites. This is the opposite of 5. Exponents are repeated multiplication, right? Exponents are repeated multiplication. What's the, oops. There we go. Anyway, what's the opposite of repeated multiplication? Opposite of repeated multiplication. The opposite of repeated multiplication is this. Negative exponents are repeated division. Think about that for a minute. Negative exponents are repeated division. A minute ago, we had this right here. Do you see? What that really means is it's would you guys agree with this? It's 1 divided by a divided by a. Oh, I don't get it. I'm sure that's what a lot of people are saying. Here's the thing. How do you do division? How do you write division? Well, isn't division multiplication? I'll spell it right this time. Multiplication by the reciprocal. Isn't that true? Isn't division multiplication by the reciprocal? So if you were going to do 2/3 divided by 1/5, wouldn't that be 2/3 times 5 over 1? Right? Multiplied by the reciprocal, that's what division is. So what's the reciprocal of a? Isn't that 1 over a? So this would be 1 times 1 over a times 1 over a. That would be 1 over a squared. Oh, wow. So when you see a negative exponent, this is not simplified. We're going to rewrite negative exponents. You have to rewrite negative exponents. Do not leave an answer with a negative exponent unless you're talking about using scientific notation. Okay, so don't do that. Fix it. So check this out. If we had something like 3 squared x to the 3rd y to the negative 5th. Well, let's talk about what this means. This is 3 times 3. Yeah? And this is x times x times x. And the other is divided by y 5 times. Do you see? So, this is how you would do this. Boom, done. You're going to rewrite that as division. This is division. So we could also rewrite it like this right here. We could say times 1 over y, 1 over y. Why did I pick 5? What a loser I am. So, same thing, you see? 1, 2, 3, 4, 5. We got 5 of them. We got 2 3s. We got 3 x's. Man, that's just fancy right there. All right, well, what about if we had something like this? What if we had something like it was 5 squared a to the 3rd, and then it was divided by a to the negative 2? Ooh, dang. Man, that's some hotness right there. Look at this. We got a couple ways we can do this. Look, the 5 squared, that has a different base than these, so it's not going to change. It's going to stay right where it was. You see? Look at this, though. Look at this. We could use our first rule. We could subtract. Oh, subtracting a negative, that would be a to the 5th. A to the 5th, like that. Oh, yeah. Or you could look at it like this. You see how this is a negative exponent? Well, with that means repeated division, and the way you do division is you multiply by the reciprocal. People want to know, where does the negative sign go? Well, where did this sign go when I did the reciprocal? Where did this sign go when I did the reciprocal? You see, here's the thing. This number and this number are not the same, but this and this are the same. You're rewriting it. You're addressing what this negative means. So watch, check this out. Ready? 5 squared a to the third divided by a to the power of negative 2. Look, here's what this means, okay? This would be 5 times 5, right? And a times a times a, correct? Good so far, right? Now look at this. Look at this. This is how do I want to say this? This is 1 over a to the negative 1 times 1 over a to the negative 1. See, if you multiply those together, you would get 1 over a to the negative 2, right? Thing is, how do you do the reciprocal? You do the reciprocal by flipping this over. Look, what if you did this right here? Well, what if we did this right here? Let's just take a look at one of them. Let's just look at that, and then we'll come back to these over here. If the reciprocal, we know this is true, right? This is true. This is 1a dividing. That's it right there, right? That's true. So because this is the same as this, I can actually, you see? That's very true. That's very true. No problems there. Now, this is also the same as, would you agree with that? 1 divided by this, 1 divided by this thing. And the way we divide is we multiply by the reciprocal. Whoa, look at that. This is equal to a. See, look, 1 over a to the negative 1 is just equal to a. This is just equal to a, and that's just equal to a. That would be, this is a. This thing right here is a for this reason right here. This one is a for this reason right here. So that would be 5 times 5 times a times a times a times a times a. That is 5a to the 5th. See, look, the way I like to think about it is this way. This right here, that says this is in the denominator, right? But this is saying we're dividing, which means it's going to be the reciprocal, which means this is in the denominator, means it's going to go to the numerator when I take the reciprocal. I already have 3 of them there. Now there are 5 of them there. Boom, done. Man, that is some fanciness. That's right. So let's do one more example of that, okay? Let's do one more example of that. Let's do 7 to the power of 3. Let's do a to the power of negative 2. Let's do b to the power of 7 divided by a to the power of negative 5, b to the power of negative 3. Ooh, man. Now, out of all this, here's what I know. Here's what I know for sure. This one's not going to change. And the reason it's not going to change is there are no other values with a base of 7. So 7 to the power of 3, for sure. Okay, now, check this out. A couple ways we can think about this, right? This is division, that's division. Everybody hates division because it gets confusing. Here's the deal. When I divide by a squared, see like that? That's the same as divided by a squared. These mean the same. These mean the same. This is not a step. This is one of the real problems with Algebra 1. Students are finding themselves in a spot where they have to actually understand the math. They can't just get by with following steps. I mean, you can, but you're going to run into serious trouble. So if we want you to be successful as you move on, you got to really understand what you're doing here. So look, this is a to the negative 2. That means negative 2. The power of negative 2 means division by the base twice. Division by the base twice. It means this. Do you see? And the way we divide is we multiply by the reciprocal. Yeah? So a to the power of negative 2 equals 1 over a squared. Those are exactly the same thing. Now, what that means is that this is in the numerator, it's going to go into the denominator. But this one's got a negative exponent as well. Negative exponents are division. Division is by the reciprocal. The reciprocal flips it over. This one is going to go to the numerator. So if we just look at this part right here, right? Let's just look at that part separately. Here's what we know. It's going to look like this. That's what it's going to be. There's another way we could do that. I don't like this other way as well, but you can do it like this. Do you see? Top exponent minus the bottom. Top exponent minus the bottom. Minus a negative is positive. Just like that. I don't like it as much because it's all mixed up in here. I would rather just do this right here. Do you see? I've got 5 on the bottom, but those are going to get moved to the top. So that's going to be 5 A's on the top, and this is going to be 2 A's on the bottom. That means there's 3 more on top. Now, this one stays. It's positive. That means times b times b times b times b 7 times, right? This means divided by b 3 times. But it's already dividing. So it's like dividing by dividing, right? This one is going to go to the top, so it's going to be b to the 10. it's going to go to the numerator because you take the reciprocal. If you take the reciprocal, the denominator goes to the numerator, right? It's just the reciprocal of this, though. Do you see? So if we were to, this is going to be our last example right here. Check this out. If we were to take b to the 7th divided by b to the negative 3rd, here's the deal. Here's the deal. Let's take a look at this right here. B to the negative 3, that's 1 over b cubed because this is repeated division. When you repeatedly divide by b, it's going to look like that. You see? Okay, so this is b to the 7th divided by 1 over b cubed. This is 1 over b cubed. Do you see that whole thing right there? Now, the way you divide, this is division, right? We're dividing again. This is division, so I rewrote it. And this is still dividing. The numerator is being divided by this. Right now, it's 1 being divided by b 3 times. That's what this is right here. It's 1 being divided by b 3 times. So now, if I were to rewrite this, multiplying by the reciprocal, right? Just like that, because it's the same thing as this. B to the 7th divided by 1 over b cubed. Multiplied by the reciprocal. Just like that. That's b to the power of 10. Boom, done. Man. Okay. So that's quite a bit of information. This thing right here has to do with why anything to the power of 0 is 1 as well. So check this out. Let's just do that one last thing right here. Let's call this right here. Anything to the power of 0 is 1. Anything to the power of 0 except for 0 is 1. And here's why. Let's say you had m to the 3rd divided by m to the 3rd. And let's say we did the subtraction. Whoa. That's true, right? 3 minus 3 is 0. And doesn't this equal 1? That's equal to 1. So it would be m times m times m, m times m times m. Boom, done. Anyway, that was a crash course. That's a lot of information. Man, that's probably, if this was brand new information, let me put our fancy pens away, this would probably be, 2 weeks worth of instruction. Woo! So anyway, let me know how that goes. Let me know if it was helpful, how I can improve, how I can help you better. And I hope you guys have a wonderful day. Until next time, I'll see you later.